At positive of cycle forward, J1.
Reverse.
Okay, so reverse bias ang diode. Ayaw mo punta na nato sa baba. This one. Okay, so reverse bias ang ato ang diode. So since reverse bias man ni siya class, ang ato ang output is equal to our input. Ilan na? 16. Okay. Now, at negative half cycle, our diode is on forward bias condition. Since forward bias mo siya pa, so V output will be measured across this branch. Okay? But this branch is equal to, wala pa man na siya. Wala pa man na siya voltahe. Switch naman na. It's just equal to 4 volts. So V output is equals to 4 volts during gahin. Okay, now if you graph it, ito na nasa bus. Okay, so if i-graph na to siya class, okay, now, this is our sawtooth wave. This is our transition voltage. Okay, above, below. Above, below. Okay, now on this part, okay, on this part, this is on reverse bias condition. On reverse bias condition, pila ato output?
16.
16. Kani, reverse bias kani. Kani. Diba? Kani siya is forward. Naka-forward ang diode ba? Ano na lang, sige. Atong unahon ang condition wherein si diode is conducting. Okay. So, unsa man nga half cycle, negative half cycle. So, on negative half cycle, our diode is forward bias. On positive half cycle,
Backward doon.
it is equal to 16 volts, which is our diode is reverse bias condition. Okay. Na yan ibutang niya class is naguna siya sa positive half cycle. Okay, suppose atong sinusoidal wave is nakayunana po. Okay? So positive half cycle bila 16. Okay. Nakayunani lang siya class because ano? Pino mo mag-ibig mo.
Yes, miss. Ang kuhan nun dyan mo siya, mga formula na dyan mo siya.
Okay.
Oh, 68. 8 ang
Okay, so this part here is naka-forward bias siya. So since forward bias, it is 4 volts. 4 volts. In half cycle,
21.
positive half cycle, our diode is reverse bias. In reverse, forward bias. Pasok to no, reverse bias. So this is equal to 16. In negative half cycle, our diode is forward bias. Therefore, it is 4. Okay. So yun na niya dire ang iyahang conducting. Okay, nagpaana ka na siya. Okay. So this is 4 at reverse bias condition 16, 4, 16, 4. Okay? Okay, nani mo siya class, i-project mo na siya, di ba? Project. siya sa atong transition level. Okay? Okay, nakainana na siya. Then, plus, therefore, atong i-cut off ang tibuok niya nga, itawag ni lower portion or our negative input signal. Then, i-clip off na to ang iyahang gamay na positive input. Okay? That's for the SO2. Okay. For example, na siya barrier potential. Therefore, it is on
Practical.
practical approximation.
Ang gana na kuanis ba sa rectifier? Pwede din masagal-sagal siya na kuanis na graph.
A diode is a rectifier. May katagay kong rectifier. Atin na sa diode.
Ayaw ka ng graph mo. Kuan. Sa ikaw yung graph.
Okay, so for practical class,
Sa ikaw sa graph ka rin. Sa ikaw sa graph ka rin. Sa graph mo, sa ikaw. Pili. Ano po? Ang model mo na. Ang tipok graph mo.
okay. So, ang atong example diri sa babaw, butangan na nato og barrier potential or yung threshold, which is 0.7 kay silikon man jud kasagaran. So, the transition voltage is still at ID. Okay? So, V, okay, dili na ni siya. Dili na siya sa class. Is it still what do you call this? Is it still a switch only? Dili na kay.
Practical na magamit.
So, although V output is 0, okay, as is mentioned na to, V output is 0 kung ito ang transition voltage. So, look, V output, V input plus 0.7 minus 4 volts equal to 0. Ano siya? Okay? Paitawan mo naman si VI. So, i-transpose ni mo ang duha to the other side of the equation. May tabo, V minus K. We have V of 4. K of 0.7. Therefore, ato transition voltage is 3.3
Miss, may tabo ba ito, Miss?
3.3
Touchscreen din.
volts.
Touchscreen din. Ay,
So, this is the 3.3 volts. Now, during our on and off state,
Miss, ang kanang kuan, Miss ba? Ang kanang battery na, kung mabali, 0 ang kuan na, Miss ba?
ay 0.
Ang battery na, Miss ba, kung mabali, kung ma-latan ang battery kay daon na ang positive.
18 siya. Kana, opposing mo na siya. Mo na i-minus. O mo mata-mata akong class, i-minus na siya kay opposing silang duha.
Pero kuan, Miss,
Kung
bali.
naka-8 gani siya, imura i-add.
Mo, lapos dahil yapong kurente na,
Kung,
Miss.
for example, this is positive, negative, positive, negative. Okay, bali ni siya. For example lang atong diode is nakabaliktad. Aiding na siya class. Series, parallel aiding. Kani opposing na siya. Okay? So, mo naka-minus na. Pero, ako class, dili ko ganun yung mata-mata o sa kay trust issues. So, I'll always make a loop. Okay?
Dahil magmata-mata, Miss, kimusaya ng numero, Miss.
Yes. Okay, so for on state, so we make a loop. So VI, okay, plus 0.7. No. V output, since our, hold on. Makabaliktad. VI at positive of cycle, our VI is equal to V output. A negative half cycle, our output is just equal to that branch. That branch is, okay. So at positive half cycle class, reverse bias ang si diode. Okay? Since reverse bias si diode, wala. Non-existing ang branch. So kung unsay output,
More input.
kung unsay input,
Wow,
wala
output.
output. Ilan ang input niya?
Oh, dili, wala yung state ay.
By 16.
Or,
voltage drop across our branch. Okay? If you will make a loop, okay, mag-loop ta, 4 minus 0.7 minus V output equals to 0. V output is just equal to 4 minus 0.7, it is equals to 3.3 volts. Yun sa pag-loop. Loop na oras. Akong loop ganahan is this way. Clockwise. So, positive, negative, negative. Equal to 0. Okay?
May tapos sa miss na sa taas ng sulod miss.
Yes. Consistent raw na siya. Basta kababa
Ay,
mo
kuhan ka na,
manipulate.
negative 7, then plus 4.
Paana ka? Sa counter?
Negative 7 plus 4.
0.7 minus 4.3 plus VO equals to 0. V output is equals to 4.3 minus 0.7. Because electric yung VO, kaya positive naman siya laan. 3.3. Same yapon. Okay. So for graph, okay? So giuna niya og butang ang forward bias C. Because forward bias ang atong diode. So during forward bias 3.3 volts. Okay, during reverse bias condition 16 forward 3.3. Okay, practical na ta class. Okay, practical approximation. Okay. Page 84 sa book. Pero kung naka Microsoft Edge ka, 105. Okay. So we have here okay. So for simple series clippers, we have ideal diodes. We have positive clipper. Okay, class. So kung i-clip niya is the positive portion, mo siya positive clipper. Kung i-clip niya negative portion, negative clipper. Okay. So for example, we have this sinusoidal signal, okay, or waveform. Kani siya class is ano siya?
Reverse.
On positive up cycle, reverse. Reverse bias, output is
Home.
0.
Home.
On negative up cycle, forward bias si diode, forward bias.
Output, input.
Okay, output is equal to volt.
Pero ang kanang miss na negative na siya miss. Negative na value ano sa
Negative siya. Because you're doing graph here. Negative yun ang peak. Okay. Now, for the negative clipper, so dili class, in ani nga series network, okay? Positive clipper. Now, what if gibali na to si diode? So, at positive up cycle, forward bias. Okay? Input, V output is equal to our input. Kani siya class is naka-idea na idea. So, this one here. In positive, in negative half cycle, reverse bias si diode, reverse bias output is 0. Okay? Now, bias na ta clippers, ideal gihapon. Okay, this is the sinusoidal wave. Inani iyang series, inani iyang clipper network. So, on positive half cycle, diode is on reverse bias condition, therefore it is 0. Okay? Kani siya class na lang siya ito na nagamay kay i-project ni mo diha, balik naman sa na siya o negative cycle. Okay?
miss unsay te mailhan miss kung kuan ka nang unsay i-clip nimo ang positive ba or negative.
Depende sa imong solution. Depende na siya.
Ay dili na mabali-bali ang kuan miss no? Ang diode.
Depende na siya sa imong design class. Magdepende ka. Dili man sa tanang panahon nga, for example, kani naka-positive clipper siya. But what if na pre existing na design din?
Like
Kung ani, positive Reverse.
Ang kanang yan yung mas balik. Kuan, palitan, doon siya ka-diode pero pulsing siya sa...
That's a reverse bias. Di ba, sa ato ang rectifier, or sa example na ko sa una, mga ano siya plus, forward bias condition. Positive, negative. Although forward bias ni siya, pag abot din na reverse man. Open gihapon ni ng circuit.
So zero.
Zero yung output. Okay? Pero kung inyong i-measure, pila ang output drop, atong voltage drop dire, inyo man ang butangan og digital multimeter. So kung unsay input dire, more po yung output, more po yung voltage drop ani nga diode nga naka-reverse. Diba na sa book? I remember kuan man ni Okay. Now this part on positive half cycle and negative half cycle, our diode is on forward bias condition. Input sa maglibog na wag inani. So kung negative, positive, so that's negative VI minus V. Okay, ideal lang na siya, wala ra. Okay, minus V out equal to 0. V output is equals to
BI.
V plus VI. Okay? Naka-negative na siya, Y. Okay? Follow up.
Yes.
Sakto rin yan. Si VO naman, negative V minus VI. Ipagawa sila dito. Ikuha ang common.
Ang ganang VMS, what's like ko na VM mo lang VTV to? Mapi.
Okay, for this part, now for this part, gibalin niya class. Okay, so gibalin niya ang positive half cycle and the output. Okay, kung positive half cycle class, so that's VI minus V minus VO equals to 0. V output is equals to VI minus V. Okay? Follow? Kung negative half cycle, this is reverse bias condition, flat lang siya. Okay? Hindi na siya negative plus, that's the peak. Peak na. Kung naka-negative, naka-inguman ani siya. Okay? Next, we have here.
Tingnan ko.
Ang gibali is ang iyahang supply, DC supply. This is the input signal. This is the DC supply. So that's on positive half cycle, our output is 0. On negative half cycle, so this is negative VI plus V minus VO equal to 0. VO is equals to V minus VI or negative VI plus V. Para ni siya plus. Ma-positive man siya din. Ma-negative din ang positive. So it's basically the same here. Kuha ra? Plus. Kuha ra na ko rin nani? Kaya kung imo na i-distribute negative V, positive V. So, ano siya? Okay, next we have here. Still the same but lahi ang orientation sa atong diode. So, positive half cycle, this is VI plus V minus VO equals 0. V output is just equal to VI plus V. This one. On negative half cycle, our diode is not conducting, open auto circuit. Okay, so therefore it is
0.
0. Okay na mo diha, mga babae.
Kami na rin, may bilhin na.
You can go. Okay. So we have parallel. So parallel na sa class. Same signal at positive half cycle. So this is forward bias. Okay? Forward bias. Atong V output is equal to supposed to be the voltage drop of this one.
Yes.
But since it's a switch, ideal. Therefore, 0. Now, on negative half cycle, ma-forward bias si diode. Forward bias si diode. Reverse bias si diode, VI is just equal to V output, pero naka-negative na siya. Okay? Kung di ka ganaan, anong inano dyan na siya? Sige, ato i-loop. Negative VI minus VO equal to 0. VO is equal to negative VI. Okay? Next, we have here, bali ang orientation. So, ang positive half cycle, siya, 0 siya. Pero ang graphing dili class is iyong giuna kung unsa ka condition, forward bias siya. Okay? Now, during negative half cycle, okay? Negative half cycle class, it is, saan na siya? Forward bias. In forward bias condition, VO is
0.
0. So, pwede siya, 0. Kung reverse bias, VI is equals to
VO.
VO. Wala na siya, positive.
Ito na lagi may skin, naka-square, ay naka-rectangle, ay halfway rectifier sa bus.
Now this one, si parallel is nakabias. Ideal yapon. So, as positive half cycle, we have VI minus V. At positive half cycle, our V output is across this one, which is just equal to our V. Ka-ideal man siya. Ano siya? So, if ever, kung ganing ang tibuok signal, dinira ko ang transition voltage diha. Okay? So, this is our transition voltage here. A positive voltage, which is this V. Now, at negative half cycle, non-existing ang branch delay, so VI is just equal to our V output. O V output is just equal to our VI. Okay? Now, this part, okay, so we have here, bali, ang iyang DC supply, orientation sa DC supply. So, at positive half cycle, conducting siya. But, unsay na itabo? Makuhaan, di ba? Are you still there? So, we have negative V. Positive, minus V minus V. So, 0. VO is equals to negative V. So, what is siya? This is our transition voltage. At negative half cycle, non-existing ang kanina branch, so V output is just equal to our V input. This time, ang i-click na to is
Positive.
ang positive part.
Pero negative input na siya.
This is a positive clipper. Okay, next we have here. Later na lang ako. So, kani, at positive half cycle, non-existing, so V output is equal to V input. At negative half cycle, conducting si voltage, conducting si diode, therefore the V output is measured across this branch. Okay, which is just equal to the negative or V. Because negative V minus VO equals 0, VO is just equal to negative V. Mag-loop. This one, bali ang orientation sa itong battery. So, VI, in positive half cycle, our diode is not conducting.
Okay.
Non-existent ang branch. Therefore, V output is equal to our VI. In negative half cycle, our diode is conducting. Therefore, our V output will be measured across this branch, which is just equal to our V. So atong V class is on the positive part. Okay? Kung palitaan na ito una ang iyang transition voltage class, wala raman na, linear na, di ba? So this is just a positive voltage. So drawing kaya positive pa. Okay? At negative half cycle, okay? At positive half cycle, this is negative. At positive half cycle, this is not existing. So V output is just equal to
Zero.
V input.
V input na yun.
Okay? Now, negative half cycle, this is just equal to 4. 4 man siya. So, 3. Okay?
Miss, ganun na kuhan, Miss? Kanang rectangle na kuhan, Miss?
Sa rectangle.
Ay,
Shani,
ay sa transition.
sa transition na, this is the part na na-click. Aside sa negative. Ano siya ka? Shading is important. Okay, this part, duha ka buong parallel. Okay? Girls, are you still with me? Okay.
Alright.
So VI at positive half cycle, this is conducting, this is not conducting. So V output, so mawala siya, wala na siya.
Zero lang kung sa Miss, ang sa akin,
So
nag-kuhan.
atong V output is across this one, which is positive V. So atong transition voltage is positive V. Okay? Now, in reverse bias, in negative half cycle,
Ang
this
pikas.
is non-existing, this is conducting. Therefore, V output is equals to this one, which is the negative of our V. This is another transition voltage. Okay? Kasabot ka ba? So, ana sa signal class,
Miss.
itungtong niya sa positive. For example, this is 2, this is 2, negative 2.
Ang kuhan na Miss, ang iyahang transition.
Transition.
Transition kayo.
Duha. Duha. Because we have two parallel. Okay. So, sugod sa signal class, itungtong niya dos straight. Okay? And this is supposed to be pana. Dos niya diha. Down. Stop. Straight. Okay? Muna po na niya ha.
On. Ideal po to.
Ang practical, katong nasa kuan. Katong naa ni Engineer Joshua.
I got an English class Miss na.
Dili Joshua yung classmate ha. Joshua nga nasa YouTube. Okay. So, tanaw ninyo nga kamura or tanaw ninyo karon? O kamo? Ha, unsan sa do? 7. Unsa man?
Tanaw lang Miss.
Sa do?
Lutuan yung utok Miss.
Break.
My brain is on break. 5 minutes.
Layo, ay layo man din.
Kasi kaya nagtong sa'yo pa 7, kaya ako meeting 7. So, tanaw ninyo or karon with me or with me na po? Watch together.
Watch together.
Or kamo na lang mo tanaw.
Kami na kurulutan na Miss kay murag tukpan. Kanang maklaro sa una Miss.
Okay na.
Mangot ka na.
Ay, katawa siya. Oo, ko daw. Buhaton sa unang class. Kaya
Ay katawalin.
kaya akong subject before sila, which is kaniman, electronics.
Yes, miss.
Wala man sila ang handle ko nila kay Sister Nesperos. Ang ME. Ang ME. So wala kayo sila electrical. So ang akong gibuhat is magtanong with video. Pero kung nasa mo na, i-post nila ang video. Kaya punta na sa miss, yun sa rin.
Mangutan nila Miss.
Isang mag-yun. Sige na. Ha?
Kami namin, mangutan na rin Miss.
Screenshot na sa mga na.
Parang mo ka na lang or...
Apas lang ng pumuntan namin.
Gawas ang
Napas sa kami sa traffic.
Kada post. Future ah. Future.
Miss, ito na eh.
Ano na lang? Ano na lang, di ba? Dapat tayo klase uma.
ISS.
Face to face. Ako rin mag face to face niyo.
Mag-quiz mo, Miss.
Facebook? Okay. Tomorrow, dili mo kung meet niya tomorrow.
Why? Why?
Na ako isumpay sa meeting ka ron. 7 to 9 ako meeting, then 9 na po, then 12.
Miss, first learn once is not adding.
Clippers o clampers. Ba't ang human? Na may clampers.
Numbers?
Clampers!
Miss, katong ng one, Miss. Katong buha ka buwan. Katong i-class ni mo.
Ano ito ba?
Okay. Now for clampers, when it comes to clampers class, dili niya i-clip off ang portion. Iya rang i-clamp to a certain level. I-clamp niya pababaw, i-clamp niya paubos.
Amo ra bitayon, Miss.
Okay. So for clamping networks, have a capacitor. Kailan mo capacitor?
Yes, Miss. Katong ng
Connected
kuan, Miss.
directly from the input to output kani.
Di ba, Miss, ang kapasitor kay naman na yung nano na
Yes.
iting.
From input to output with a resistive element in parallel. Okay? Si resistor parallel ni diode. The diode is also parallel with the output signal. Okay? But may or may not have a series DC supply as an added element. So, na instances class, na instances na siya supply na DC or wala. Bias ba siya or wala?
Ining so bad ng kuan, Miss, kanang may kapasitor kay kailangan pa namo i-kuan convert ang kini ba nano man ang kuan, Miss, ang measurement sa kapasitor.
Kung nano na.
Sama sa puso na. Jumpers.
O ba? Okay. So for clampers, we have also steps, right? Sequence of steps that can be applied to help make the analysis straightforward. Okay? It may not only approach to examining clampers, but it does offer an option if difficulties surface. So step 1, start the analysis by examining the response of the portion of the input signal that will forward bias sa diode. So tanang niya class kung saan condition nga mo forward bias sa diode. Next, during the period that the diode is in the on state, assume that the capacitor will charge up instantaneously to a voltage level determined by the surrounding network. Because the capacitor has the capability to charge and discharge. Kana atong cellphone daghan kay nagkapasitor. Yes. Okay. So for the ilang sa akong discuss time constant. So we have here an example of our on and the capacitor charging to a certain voltage. Ano man siya class? Kung conducting ang ato ang circuit, mag-charging na ang ato ang capacitor. Once nga ma-turn off na ato, kay positive off cycle, negative off cycle ba yan? So for example, naka-forward orientation ng iyang diode. So at positive half cycle, so forward bias. Na itungtong niya, i-shift niya o negative half cycle, so ma-turn off ang circuit. So that time, ang atong capacitor mo discharge. Okay? Mo discharge kay kuhaon mo to iyang voltahe. So silbi nag-discharge siya. So inigsaka na po niya at positive half cycle charging. Okay? So dapat class ang charging mas paspas siya kaysa sa discharging. Kaya kung dugay ang atuang charging class niya, dali ra kay siya mo-discharge, mahitabo
Buto.
zero ato ang supply. Dali malubat ang atuang cellphone.
Kato ng kuan, Miss, no, kato murag lingi cylinder.
Daga, mylar na siya. Na ay capacitor, laylay ang nang sa capacitor. We have an electrolytic capacitor which has a polarity, positive, negative. And a minor, wala siya polarity. Pwede na nyo bili-bili. Okay. So assume that during the period when the diode is in the off state, the capacitor holds on in its established voltage level. Okay. Throughout the analysis, maintain a continual awareness of the location and define polarity for V output to ensure that the proper levels are obtained. Okay. So we have here an example. Okay. Bali iyahang
Yung tuyo.
bali ang iyahang
DC supply.
supply. Tanaw ninyo class, di ba na V output dire? Pero napod siya define nga V output here. So ang iyang buhaton is negative V. This is also V. Gitawag na siya o VC. Okay? But since VC is just equal to V, okay?
Muwagin na siya sa resistance. Hindi, magawas na yung ng VO. Giano.
VO is equals to V.
Mapega pa ng BCL na. Nagkibilo na eh. Masa na siya? Ang nangyala naman.
Okay. Now, if you look at this part class, during positive half cycle, okay, kung balik during ano na
Kuya power stream. Ay, book niya yung dial miss para kuhan. Para
naman dyan na yun. Yung mo alam ko sa iya ha, bakit sa okay, so we have here a capacitor, natay diode. So, during a positive half cycle class, okay, so, di ba naman na siya yung VO?
Bali ang kuhan miss, ang battery. Bali ang battery. Negative ang dito miss eh.
Capacitor na.
Forward bias.
Orientation sa...
Forward bias.
Now, during forward bias condition class, okay, so si V output is connected here. But during ideal again, during ideal, switch ra na siya. So, since switch lang siya, wala siya iyahangagahin na voltage. So, 0. So, at forward, at positive half cycle, okay, V output is 0 volts. Now, during that voltage is equals to 0 volts, so this is already 0. 0 na rin, di ba? Now, to find the VC, we need to find VC na class, which is the voltage drop across our capacitor. So, load V output minus VC. Okay? Since V output is 0, minus 0 equals 0. 0 naman siya. So, mawala na siya. So, VI is just equal to C, or V is just equal to C. Now, during negative half cycle,
Wala siya ang paano sa kanang instance kay kung forward bias.
yes, kung inani ang iyang clumper na network. Now, during negative half cycle, so this is
Negative positive.
okay.
Reverse.
So, reverse bias. So, wala ni siya class. Now, if wala ni siya, existing ni siya. Okay? Kaya wala man ni. So, we have another output here. So, we have negative VI
Plus.
plus man.
Ay, minus.
Minus
VC.
VC
Plus.
minus VO.
Ay, minus.
Ayaw, kung niya. Asa man tali gawas?
Ay,
Equal to 0.
Boss.
So, V output Negative VI, VC is equal to V. Okay? Or VI. Di ba? VI man niya.
VI miss, VI miss.
Namo ko diha. So, VI minus VI minus VO is equals to 0. So, V output is just
VI.
negative twice of our VI. Or
Negative
twice
2 VI.
negative 2 of our V. Kana.
Ay miss, ang VI gani miss usay na sa video PT. Katong sa video mismo.
Sige. Wala pa tayo ni kuan og threshold. Kuan pa na siya. Iyahang input. Okay. Check the total swing of the output matches of the that of the input. Okay, ako na siya explain later. Ang meaning ra diha ni class is kung unsa ang peak to peak value sa atong input, dapat i-output signal ninyo moray peak to peak output sa inyong signal. Why? Because we are not clipping, we are clamping. So imo ra siyang gibira, gidusok paubos imong signal. Kung imo ra bira-birahon, meaning same ra gyapon na sila og peak to peak. Lahi lang sila og lugar. Kopya? Okay, for example here.
Nanulagit si miss.
For time constant, next na lang muna i-discuss ang time constant.
Mga ano?
Okay. Now, at negative half cycle, di ba, unahan mo na itong tanaw class ko, asa siya mo forward bias.
Ay, dito sa kuwan, di ba? Dito sa dito na. Nakaparting mo dito na sa
Okay. Now, during negative half cycle, okay? Now, during negative half cycle class, our diode is
ay,
forward bias. On siya. Okay? Since naka-on man siya class, our V output is across, where is it? Oh, the word.
ay, ang capacitor na
Basta, 1 micro na.
ay micro dito.
Micro na siya. Okay. So, our voltage is just across our V. Kay ideal man si diode, diha. So, V output is equals to 5 volts. Okay? That's for our negative half cycle. Now, during our
Labo ba meeting is?
hatag na sila upuan. Late. Okay.
Sige mo,
So, for positive half cycle, so our diode is on reverse bias condition, therefore it is off. Now, since it is off class, unsay may tabo? Ang ato ang looping is padong direct. Wala reason na yun. Okay. So that would be B bilang minus, di ba namin kapasito?
Miss, VC.
Minus BC
Bigyan na may call.
Minus VO.
VO is equals to VI minus VC.
VI minus VC. Now to find VC,
VC is equals to
okay? So to find VC, we can make a loop here. So that's VI. To find VC, gawin mo lang ako. Okay, so look. So we have here VI minus VC minus V equals to 0. So VI is 20 minus 5 minus VC equals to 0. VC is equals to 20
negative 15.
Hindi na yung ba na tulog?
wait lang. Ako sa'yo.
Ay, kuhan ito ka na. Dahil ko lang ako. Si Raiko, si Bates, pero ko na si Kuhan, si Joel, si Kuhan, itong regular, sorry sila. Okay, Kuhan mo.
Sakto ba? Pila yung VC diya? Basta ko. VC 25. Oh yes!
Mali.
Because it is forward bias in reverse, in negative of cycle. So this is negative VI. So this is 25. VC is positive 20. I-transpose ba? 20 plus 5. It is 25.
35 ang Kuhan, miss, ang
25 ang
busy.
VC. So V output is equals to 20.
Minus 25.
Ito ba?
Oh, miss, i-disregard lagi ng Kuhan, miss, ang resistor, miss.
Sige, disregard. Wala man ito nagamit sa kapuan. Resistance niya.
Ah. Oh, wala man po tayo ipakita ang current. Ang voltage man din.
So, positive of cycle 10. 10. 10. Bali din ang orientation sa kapasitor. Damn.
Oh. Ay, ito siya bola.
negative VI minus
Suga. Gawa na.
Okay. So at negative of cycle class, wala siya mausap, it's still 5 volts. Now on positive of cycle, this is 10 man. So positive VI, balida yung orientation ay naaral ko positive negative. Okay. So positive VC, dayon negative of cycle, so non-existing ni siya. So it's just VO. So i-group niya pa doon siya sa VO. Positive, negative, minus VO. Okay, here, equal to 0. Now, since VI in positive half cycle is 10. Okay, 10. Ang VC nga nakuha is 25. Minus VO equals 0. Transpose VO, 10 plus 25 is 35 volts. So, at positive half cycle class, na siya 35. Okay, here. Dire, 35. Naman siya output in negative half cycle, which is 5 volts. On positive half cycle, we have 35. Negative half cycle, we have 5. And for positive half cycle, we have 35. Now, dapat, ningon siya sa last step. Dili na sa, later na ko na i-discuss ninyo ang time constant ko sa. Now, ningon man siya nga sa last step dire nga, check the total swing. Okay? The total swing should be equal from the input to output. So, tanaw na to class. Pila man dire? Pila ang peak to peak?
10.
Total swing meaning peak to peak, 30. Pag abot dire, pila peak to peak?
35.
30 gihapon.
Ah, 30.
Because we have
Gig-clamp.
5 naman.
Gig-clamp pa
Okay?
rin.
5 naman ang ato ang initial position.
Alright.
5 to 35. So 35 minus 5 is 30. So therefore, sakto rin pagka-clamp. Okay? So we have peak to peak, 10 plus 20 is 30. 35 minus 5 is 36. So from here, ingon ani siya class, okay? I-clamp siya pataas.
Kaya ka ng kuhan is ko. Ay, baka mo yung kuhan. Pataas. Okay, 30 naman ng kuhan.
Okay. So i-clamp ra ni siya pataas class. Kani siya na yung 35, kani nawa jud ni siya. Napunta na siya dire. Okay? Pero luwa siya maklik, imo ra man gibira ang signal. Kuha ra sa clamper. Class?
The process points.
Okay. So in here, natay example. So example 2.22 using silicon diode, practical na ni siya. VK, knee voltage na siya. Okay, knee voltage. Equal to 0.7 volts. It's equal to knee voltage, threshold voltage, barrier potential. Okay. So for the short circuit of the network, nasa na figure? Okay, nasa babaw. Okay. So VO can be determined by